real treat to finish off the conference today. Javier, where are you? Javier, we're very excited about this. We want to hear a little bit more about the Biosphere Reserve and the tools that are being put into place to make sure that investments don't contravene any of the requirements of biospheres and the ICT tools at your disposal. Javier, please, over to you. Thank you very much.
Well, good afternoon. Thank you very much for inviting us to show our work in terms of general sustainability and also in specific in energetic issues around Tenerife and the whole archipelago of Canary Islands. My name is Javier Pérez. I come from Interra. Interra is a company who has been building this kind of tools, ICT tools, in order to promote sustainability in a general sense, and especially in issues regarding to small territories like the islands. It's nice to see that Nemesio finished his talk with the winning image of NASA's tournament or NASA's contest, which for year 2013, and this is the winning image for 2014, for this year, from NASA's images. It's brought here because it looks like the islands were sailing northwards and making wakes at the south side, but it's not actually the islands who moves, but it's the opposite. It's just the wind which is blowing this direction normally and make these wakes where the sea surface conditions are so different that they can also be detected from satellites, the difference in reflectivity which we have, and this is one of the main reasons we are talking here about renewable energies and so on. So I'm dealing with this energy not in the interior of Earth, but rather at the outside. So I'm going to start to put it in context. For putting it in context, I will use, I don't know why this is not working. Sorry. Because I know that the voice is up and down, now 3. Ooh. So, for putting this image in context, I think it's too high. In context, we are going to use the IC tools we are developing. We are developing IC tools on behalf of UNESCO in the first time, and on behalf of Biosphere Reserves of the Canary Islands in the second time. So we are using that image we have seen is now put on this whole context, which is Biosphere SMART, you know. So this was the image. And we can use this platform to put it into context, for instance, regarding this solar radiation above this part. What we are looking here is a map of solar radiation and the availability of direct solar energy distributed the northern hemisphere. So we can see Canary Islands. This picture is taken as a 22 years average of NASA's measurements about solar irradiance. So it's a very good approximation of the amount of energy you can expect to have in this area. You see, we got huge amount of energy directly from the sun. You know, this is somehow reflected over sea surface temperature. So we are, you can see this kind of relationship. This is higher temperature here and lower temperature here. You can see it makes sort of kind of a gigantic whirlpool clockwise rotating in the water that makes part of the fog you have seen just right now. And also related to this is also the wind circulation. It is also part of this North Atlantic subtropical gyre, which is rotating clockwise. This is the general atmospheric circulation. So the archipelago is located here, so it's benefiting from large amounts of winds in quasi-permanent Atlantic trade wind cells, which are humid, and they bring that water you have over there. And there is a feature that is quasi-permanent, and the wind is steady, moderate to strong throughout the year, or almost throughout the year. So we benefit from huge amounts of direct energy from the sun, and we also indirect energy from the sun in the form of winds. This is the so-called trade winds we are talking in the previous talks. When the wind comes, it interacts with topography. Here there's a depiction of the orientation of the island in GIS terms. This is what is called an aspect image. So it distinguishes which canyons or valleys are facing which parts of the island. Also, indirectly, you can see an indirect depiction of the altitude, but it's not the main issue of this image. You know, this is almost 4,000 meters in here, 2,500, 15 or 2,000 meter high, and less than 1,000 in this area. So when the winds interact with topography, you get something like this. This is the wind distribution. When it interacts with topography, it's accelerated at the edges of the islands. You can see here this kind of colors means higher velocities. This is 40 meters wind resource, 40 meters high wind resource. So you get places where you expect to have more wind harvest or more wind energy providing coming from the wind. When you're dealing with wind, you have to take into account also this what is turbulence, because you need good quality winds, so you need steady flow winds. You prefer that. And when you are dealing with topography, so that induces instabilities and turbulence in wind flow, and reduces the quality on the amount of energy you can harvest from a given wind velocity. So that is more or less what is the context. As a result, there are several areas normally located at the southeast edge of the island, which are benefits for very nice conditions for wind farming, as we have seen. In several islands, there is also the same possibility at the northwestern edges, but that depends a little bit on topography. So this tenor is not as good because this macizo de tenor is very high. So it induces a lot of turbulence in the wind, and maybe it's not so useful for harvesting wind energy. And this is more or less the picture of the major wind farms along the archipelago. Nevertheless, wind energy has little penetration in the archipelago, even if you compare with the rest of Spain. We get a lot of facilities in there, but we are only supplying about 0.7% of the total demand of the energy which is required in the Canary Islands. That's something we have to think about. And what about the people requirements? People has energy requirements. And that means energy is the only physical quantity you can translate into money. So energy requirement means energy budget, especially in an isolated place or far away from the places where the energy should be produced. So what is one of the goals in energy requirements in respect to people in Canary Islands? So reducing external dependence should be one of the goals. Which are the environmental requirements? Of course, reducing carbon footprint. And how to pursue realistic objectives? Well, we think that the way to set realistic objectives and also to test if we are doing things okay is adaptive management. Adaptive management is a structured way of planning and acting in those issues which are related to territories. It's have a lot to do with knowledge, applying knowledge to management, and so it's well-structured, open standard that tends to be optimum for environment and optimum for people. So, given a lot of information is available, why not put it into work? Information is provided mainly by ICT tools. They are relevant data, but must be translated into useful information. It's not the same data and information. To promote a sustainable future, we must rely on knowledge. Knowledge must be accessible to all kinds of users. Who are users? Users could be a policymaker, user can be any citizen, user can be anyone. Anyone will have different requirements. The participation needs qualified information. If people is about to participate in taking decisions about their environment and their energy policies and so on, needs qualified information. And also the last premise is that everyone can benefit from territorial knowledge. This is so. How to do it? Yeah, I have to apologize for some Spanish words in certain slides. Hope you understand anyway, because there are icons at the side and the words are quite similar to English words. So when dealing about sustainability, sorry for mispronunciation, we are dealing with mobility, with climate change, with saving water, with tourism in the case of Canary Islands as well, to develop and research welfare, economic welfare, and also, of course, about sustainable and efficient energy, which means normally renewable energy. So, on behalf of UNESCO Man and Biosphere, we developed this first tool, we call the core tool, which is Biosphere SMART. We pretend that tools to be for helping to achieve a sustainable future, or we call them also territorial intelligence. I'm talking about this first. This is the initial initiative about this, and then this is a step forward, which we call smart biosphere research. And it was So the core, the initiative, is Biosphere SMART. Biosphere SMART initiative was adopted by UNESCO's Manual Biosphere International Coordination Council, and that's that date over here. So when a territory is awarded as a biosphere reserve, it is committed to accomplish several mandates. Namely, these are the mandates. And this is the philosophy which is behind these tools I'm presenting now. Yeah, to combine environmental protection or preservation with social and economic development, to promote participation, good practices, good governance, and to serve as poles for education, knowledge, and research. So this is the philosophy which is behind Biosphere SMART. And this platform, it is you get. It's not, you cannot see this website. You can use used by UNESCO to share ideas, knowledge, and disseminate best practice and other initiatives. Namely, important is Rainforest, which is UNESCO's initiative in terms of renewable energy. The main characteristics, okay, you get access to the whole network of biosphere reserves, which is these red dots here. You can see how many are there in the Canary Islands. For every of them, you get a glance of information, geolocated with the positions of reserves. You get some links in each of these cards, let's say, or pop-ups, and where you can visit or see the map of it, see videos about it, or the social networks they may have, if they have, all over this the world network of biosphere reserves. At the same time, they are classified. It can be also contextualized by other relevant information, like, for instance, threats, climatic or aridity, deserts, not only environmental information, but also socio-economical information. Its purpose is also to promote this participation and transparency. And the first step should be provide a unified access point for qualified information and facilitate contribution by users. There are several ways where users can contribute. For instance, we have seen here many initiatives that should be awarded as best practices, especially if we're talking about these ITER initiatives. So the only thing you have to do is go to the main menu and see best practices and submit your best practice. That will get to the Man and Biosphere Council, and they will promote your actions, and this would be a very nice window for visibility throughout the world. If you consider you are doing a good practice. Going a little bit, well, there are several ways of public participation. You can also reach us by this tag in here if you find anything which is wrong or something you want to be changed or whatever, or suggestion or any comments. You just click on this tag, and you can directly connect to see, okay, there's something missing or whatever. It's very easy to use because it's quite similar to Google Earth, which everybody knows how to use. And sometimes you use this maps, geography, because within biosphere reserves, you have to know which parts are you dealing, because different areas have different regulations in terms of what you can do in there or what you can't. Going a little bit fast. It's hosts also this Rainforest initiative, which is also from UNESCO, is specialized in sustainable energy, in renewable energy. You can use this here. In good practice, if you drop this menu here, you will find, okay, submit your best practice, and you submit it, and it comes to the council, and they decide if your practice is good enough, they will promote it to here. So you can be here, and this can be accessed from any place of the world. And then, to specific locations, I'm talking, because we are running out of time, I am going quite quickly on this downscaling. What if we could introduce or include more information, several geomatic techniques, I mean, small programs, small technology in this? For instance, allowing basic measurements, areas, distances, especially interpolations, providing derived quantities by means of simple models, for instance, recurrence or risk assessment. How often would you get a certain amount of rain in a given time or in a given position, or derived quantities like evapotranspiration or hydric demand, hydric stress, or whatever, would be better. This came out in what we call digital observatories, which are these simple but useful smart tools to help to accomplish Biosphere mandates, as I told you before. We got 2 of them right now, Fuerteventura and El Hierro. Okay, so the observatory is composed of 3 parts, which is a GIS system web, where you can view and also interact with these maps and geo information, an indicator system where you can be informed about what is going on in terms of socio-economical aspect, and you can also a web page which complements them both. Okay, so an observatory composed of web portal, GIS system, indicators, tools for visualization and analyzing it, certain sustainability gauges, which is a resume, very easy to understand performance indicators, and also platforms for e-learning and training. We also added this nowcasting and forecasting of weather conditions in terms of what's happening in atmosphere and also in the sea, wind, waves, humidity, anything from state-of-the-art models which are connected to this platform, and in some cases some specific analysis tools like numerical models on what to do with potential adverse events or assessments about placement of facilities or whatever. So the virtual observatory, this again, just to depict how it is, GIS system, indicator system. I'm going through this because GIS, we have been looking at pictures which are already taken from the GIS system. This is a resume, which is this is sustainability gauge, which is very easy to understand how if we are accomplishing or not, and these colors, green, yellow, red, indicating what is standard, international standards on quality, on achievements, And in some cases, we can even add these mobility applications where you can use it from smartphones or tablets. This is what we call indicator viewer. It's a web page divided in four quadrants. The first will be this, where the strategy and objectives in sustainability, which is water saving, which is agriculture, which is population, which is unemployment, which is preservation, natural preservation. When you select one of these areas, you deploy or you pop out or down, better, a series of individual indicators that you can select here and you can visualize here. These graphics are fully functional, so if you move with your mouse, you move over these graphs, you will see what is in them, so you get access to real facts and figures as well. And there's also a connection with the GIS, because sometimes or many times these indicators are related to specific locations. Oh, all right. So as basic performance, this gauge and tells you through the time overall assessment performance. For instance, what is consumption of energy, electric energy, or the CO2 emissions per capita. They are easy to understand and reference to objective standard adapted by international councils. So these colors means which is considered good practice, not so good or bad practice. You can even use this GIS to sectorize. In this case, this is energy consumption in El Hierro, electric energy in different places, different locations. I'm going a little bit faster. This is again, which is the indicator viewer. It manages a lot of kind of indicators, planning actions, and also evaluating the results. So they are also performance indicators. Everybody can check if we are doing good or not. So you put in front of your people and you show what you're doing and you show what your results are. So that's transparency. A little example to use this to assess energy issues in the case of Hierro. El video has shown us about this huge project, which is Corona del Viento. It's an hydroeolic station, and we are going to see which amount of energy, more or less, is about to produce. With our indicator viewers, you can analyze directly in the web how is the behavior of the energy consumption in El Hierro, and also you can sectorize it, which is in electric production, which is in vehicles, which is distributed in gas stations or liquid gases. You can also learn how is the evolution of the population in there, which is the area. You can work out very easily, which is the amount of energy for the whole island per day, for instance, or per habitant, and what is the total annual demand of electric energy, which is about 36 gigawatts, and that's the tendency. Okay. You can see which are the main components of this energy consumption, which are in production electric energy. We are using about 10,000 equivalent petroleum tons. I don't know how to say that in English. It's tons, equivalent petrol tons or something. Yeah, the amount of fossil fuel that you're using. You can compare it with this total emission a long time as well. This is CO2 emissions. You can work out, okay, for any megawatts you are producing, how many tons of CO2 you are producing as well. So you can easily work out, and you can see in several important areas like water consumption, electric power consumption, emissions, and in this case, this is about glass recycled per capita in every case, you see. So this, the wind hydro pumped, you know, most of this energy budget is related also to desalination of water. They're using electricity to desalination of water because there are not enough water for the population in there. So this is what they have devised. It is a wind farm gathering energy from the wind. And as the wind is not a stable source of energy, they prefer to use that energy to pump, to raise water into a reservoir, and then release that water to a lower reservoir, then taking from it a more stable source of energy, which is hydroelectrical source. Part of this energy is also used to run a desalination plant. What to expect? Okay. So you can easily work out scenarios, taking into account population growth or not, with the business as usual, and about this projection is for 2020. You'll have without increment in population about 38% increase in CO2 emissions, and if you use a growth rate of about 0.1, it will be an increase of about 50% in the next 6 years or so. What will happen if Corona starts operating? Well, it's going to depend on the overall performance of the system. There, you know, from the school, you know, energy cannot be generated nor destroyed, but it changes its form. At each time it changes form, you have a factor of efficiency. You lose a part of energy. You cannot figure out the whole process in just one number. It's going to depend on the condition and the overall performance of the system, but it could be about of it's 12 megawatts power wind farm, what you have in there, and it could reach about 70% of the total electric energy required for the island. So that means a decrease in CO2 emissions, a considerable decrease in CO2 emissions as well. At the same time, we can use the tool for assessment about this solar energy. You can work out, okay, what is expectable for a given area in terms of watt per square meters per day. If you're planning, for instance, a photovoltaic installation, or even if you want to heat water with solar power, we can use something similar, very similar, also with wind. And yeah, just to finish these tools, part of these tools are devoted to training and to gain knowledge from putting together all this kind of information. That because we think that the fusion of the information is much more than this mere addition of information items. So what you get by the synergy of all this information is quite a good idea of a good depiction of what is going on. And we also have some other tools I'm not going to show now, related to building sustainability as well. There are some regulation, or if you can use these tools to see if your building strategies are following regulation in terms of this sustainable building and so on. Also, you can use this to establish which is required for warm comfort in your buildings. You get as many uses as you can imagine from the synergy you get by putting all together. Thank you very much.